Cool. So yeah, with that, welcome everyone. This is an instruction session on unit testing, iOS unit testing, and the purpose of this class is twofold, right? We're going to be going through the basics of unit testing. We'll do some live coding, and we're also trying to bring attention to Underdog Devs. So having said that, I have a presentation here ready. Let me see if this works magically. Yes, it works. Okay, so intro to iOS unit testing, or how to pour code into your code so you can code your way out of incorrect code. Yes, this is a lot of code. It's going to be really fun. Um, the agenda for this 1 hour session, hopefully it runs closer to an hour, but we may run like 1 hour 15. Um, Basically why we're here. Underdog Devs is the reason we're here, mostly. I'll speak a little bit about myself so that you guys can know that I'm not just a crazy person, which I am, but I also know a little bit about iOS. And we'll get to the meat of the session, which is what is unit testing. We'll do some live coding. We'll code a single unit test. I'll explain the concepts and you'll see the code. And once we're done, I'll show you a few links where you can keep reading. I'll upload the code to GitHub and the presentation so you guys can see the final product. And if you want, you can ping me on Twitter, ask me questions after the session. So first of all, Underdog Devs, the whole reason I am giving this talk is because Rick here, who is now the host of the meeting, has been trying to build something really cool from the ground up, which is trying to support the formerly incarcerated and disadvantaged getting into the software industry, right? So yeah, he has got a group of persons together that are in the industry, seniors, juniors, basically people that already have a foot in. And what we're trying to do is we're trying to help people that really require a lot more help than others trying to get into the community. Currently, Underdog Devs is relying 100% on volunteers. So if any of you have 30 minutes that you can spare, an hour to hop on a Zoom, help someone out with coding question, networking question, really anything that you've learned throughout your work in the industry, it would be really, really valuable. Currently, like for instance, myself, I am a mentor, so I provide sage, sometimes incorrect, but sage advice to newcomers. And if you're a junior, like we've gotten this question already, like I just started out, can I really help? Yes, of course you can help because you are a peer to someone that's going into the industry, right? So they have the same questions as you. They have some of the same requirements and needs that you do. So it's always useful to be helping someone that's your peer or someone who's slightly behind you. Teaching is, I've tweeted this recently, teaching is partly a selfish endeavor, right? I'm here teaching because I want to learn more. I can't teach unit testing unless I know about unit testing. So that's a great way to go to improving your skills. Going from junior to mid-level or senior, teaching is a great way to do that. More plans to help are coming down the line. If I don't bomb and have to move to a remote village, you'll see a little bit more about me, and hopefully other seniors will come step up and help people out. So, Rick, I don't know if you want to say a few words or if I should keep going.
I think that was it. I mean, I'll just say that thanks for everyone showing up, and Fernando for doing this. If anyone does want to help, just reach out. We're always trying to get more people to help. Working on volunteers, as you can imagine, we all have day jobs, so it can be hectic, and so the more of us, the better. And yeah, we're just trying to create opportunities where there weren't any opportunities before, or at least where people have had a really hard time. So yeah, we're open for any people that want to come in. And thank you again, Fernando. This is super cool of you.
No problem. Thank you, Rick, for making this happen. And now about myself. Yes, those who know me know that I love talking about myself. So I had to make this slide here. Um, I'm lucky enough to have 10 years of experience. I started out in around 2009, 2010. I've been working, I have worked for smaller startups, like 5, 6 people. And I've also worked with publicly traded companies, right? Thousands of employees, uh, tens of thousands, hundreds of thousands of customers. So I've been all over the place when it comes to scale. And for a decently long time, probably around 5 to 6 years, I've started teaching a little bit more formally. Uh, I got a job at Big Nerd Ranch. I've also taught as a mentor in blog at blog.io. And most recently, I was a part-time instructor at Lambda School. Uh, some of my apps have won a few awards. 1 second every day, the app that's right there, won the Storyteller Within from Apple in 2019. And another app that I worked on, one of the startups, was a top 10 app at the ERA Accelerator in New York. So just a little bit of fun, fun side events. Um, I have a bit of product and project experience. I've moved, I've worked both as a senior developer and as a lead developer, which means helping out with where the product is going, uh, guiding other developers, and project experience, budgeting, estimating, basically handling engineering manager experience, things like that. I have been iOS only. I don't know any other languages, which I think most people would. Twitter would kill me for saying something like that. But I only know Objective C and Swift. And a fun tidbit is I bought my first iPhone without knowing if I'd be able to use it. I currently live in Mexico. I've always lived in Mexico, but I currently do too. And so the first iPhone was singular only. So I went up to the States, bought it, and I was just stuck in the lock screen for like 2 weeks until the dev team pulled through and I got like to use the real deal. So yeah, another fun thing. You can follow me on Twitter at from junior to senior. I have a weekly mailing list with 15-minute exercises if you want to subscribe, and you can ping me if you have any questions. I'm happy to help. Uh, if I have time, obviously. Like Reed said, I do have to eat, so I do have a day job. So we get to the interesting part of this, right? Um, well, I was interesting too, but you guys are here for unit testing. And what exactly is unit testing? In theory, unit testing is one of several different kinds of testing that exist on iOS. We have functional testing, which is part of a superset of unit testing. We have UI testing, and we have performance testing. Unit testing in its essence is a function that tests other functions. So these units that test other functions can be automated, and that really gives them a lot of power, right? They help you validate the logic and or the performance of your app. They can be plugged in into a continuous integration setup like GitHub Actions, Fastlane, things like that. And so what you can do is every single time you commit your code or every single time you merge a pull request, uh, those tests can be automatically run, and it can tell you, yes, everything is going right, or no, there was something in this specific pull request that broke this test, right? So unit tests, one of their main purposes is to protect against regressions. Does anyone know what a regression is?
Making something worse, I guess.
I like that. Yeah, making something worse. So, in general, in software development, if you have a function that's already working and you introduce a bug to that function, that is called a regression, right? It was previously working, now it's not working, so it's regressed. And unit tests protect against that, right? For example, if we have a function that makes a string all uppercase, and we introduce a bug where only the third letter is uppercase, that is a regression. But if we have a unit test that's always checking that a string A is always uppercase, as soon as someone introduces that bug, that test will break. And so you'll be immediately alerted that, hey, something went wrong with this commit or this pull request. And Not only that, but having this context, this foundation opens up the possibility of test-driven development. I don't know if you guys have heard about test-driven development. It's not very common on iOS, but test-driven development is basically where you start with the tests, and the tests try to validate an empty function, right? So you design our uppercase string function, that one is empty, and you start designing tests against it. Like, what happens if I input an empty string? What happens if I input a string with just emojis, a string with emojis and uppercase characters, blah, 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 right? You can think of 100 different scenarios. So you start coding all of those scenarios. And once the scenarios are coded, the tests, you start working on the function so that all of your tests pass. When all of your tests pass, you're done coding. That is test-driven development. Any questions up until this point? Okay, perfect. So feel free to interrupt me at any point in time. We also have a Q&A section at the very end, but if I'm going through something and you're like, "Well, I didn't get that," just ping me in. Just speak up and I'll stop. So the previous slide was the theory, right? In practice, we're still constrained by reality. So this is code that tests other code. Mohammed asked a little bit about this before the lesson, which is that, well, if I'm alone, I'm coding, should I be unit testing? Most of the time, the answer is no, because code is expensive, right? When coding, you introduce bugs. You need to have someone review them. You need to test for like the correct functionality, and you duplicate that effort, because not only are you testing your app's code, you're testing the code that you built for testing, right? That's why the intro was like code to test code, 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 code. This is expensive. You have a developer doing something that's not contributing directly to features, to bug fixes, to tech that. This is a whole nother thing. So should I be doing it? In general, yes, they provide incredible value when they catch bugs, right? Regressions for bigger companies can be very, very expensive. So unit testing are your safety net. Usually what I've seen happen in my experience is you can spend like a day, at most 2 days, to add coverage to a very important function in your app, right? The function that downloads the timeline if you're Twitter, the function that adds contacts if you're Facebook, things like that. You can focus your testing on those functions which are mission critical, and then you add a bunch of tests, and that way you can catch any regressions in that part of the code. We'll also see it in a second. It's very satisfying when you run your code and you get all the green check marks. I live for the endorphins, so having your code be like, yes, this is correct, that's amazing. It's just a great feeling in general. That's why we're coding, right? Because it's like the feeling of rush, the rush of I can make anything happen. Um, Obviously, like I said, they're very expensive. So most of the time, they're really at the bottom of the list. If you have a junior developer, if you have like some companies offer like 4 hours a week or 8 hours a week to do whatever you want with your code base, like that's not a feature. I've seen people go in and say, I've been bothered by this function for the longest time. They refactor the function and then they add unit tests. So again, constrained by reality. Are they great? Yes, they're great. Are they usually at the top of the list? No, they're usually not at the top of the list. And how exactly are we going to be testing the code? We're going to be using assertions. An assertion is basically what it sounds like. We're going to be validating that something is true, right? We've downloaded 10 tweets. If that is true, continue. If not, the test failed. Um, Xcode provides us an environment called XCTest. And in that environment, all functions with the prefix test will be run as unit tests. Any function that doesn't finish execution because it failed an assert is considered a failed function. And the purpose in the end is to validate each logical step, right? Did I download this? Yes. Did I parse it to JSON? Yes. Did I send it to the correct object? Yes. If any of those steps fail, that's a regression and the unit test will fail. And so, yay, enough about me talking, and a little bit more about me talking, but this time in code. This is the repo that you have in that you if you want to follow me around, you already have it in your Mac. If you don't, it's in GitHub, and you can check it out after the lesson. It's a very very simple application that I built. All it does is consume an API request, and downloads a bunch of JSON, parses it into an object, displays it into a table view. That's it. We'll do a quick rundown, but as you can see, like it's literally only a table view. Nothing happens if I click. And these are just the names of different planets in the Star Wars universe. The Star Wars API is very useful. Doesn't need like setup with keys or anything. I could just hit the API endpoint and keep going. So right here, I have a class called network controller. It has a base URL. As you can see, the base URL is the Star Wars API URL. And it has a single function called fetch planets. This singular function has a URL, which is composed of the base URL / planets. It creates a URL request out of the URL, and it begins a URL session data task so that it can begin downloading the data. Once the data is downloaded, we'll get it here, and we're just validating that everything went right. There are no errors. We got a response from the server. The response is an okay response. The data actually exists, and the data has been parsed from pure ones and zeros or bits and bytes into a JSON, and then into this planet result structure that I have right here. Right? So going out to the network, download the JSON, parse the JSON, transform it into planets. And after I transform it into planets, if everything went right, I go into my table view controller right here. And as you can see in the view.load function, just so basically as soon as the view controller loads, we get our own network controller and we fetch the planets. After we get the planets back, we either get a failure, if a network error, if the JSON is corrupt, things like that, or we get a success with the planets right here. And if this is true, we assign the planets to ourselves and then we reload the data. And this is just simply boilerplate code. Number of rows in section, a single cell with a text label. Any questions up until this point? Okay. Even though this is a very simple application, it's actually a very, very common action that you will see all over iOS apps. Network, download JSON, parse JSON, display JSON in many ways, shapes, or forms. Doesn't matter if it's Swift UI, a collection view, a table view, labels. This is the basics of it. So if you were to start a new job today, you're more than likely to work with networking code at some point. So what we'd like to do is start testing this, right? We only have a single function, fetch planets. So let's start testing whether the behavior for fetch planets is correct or not. If you want to follow me, select the project right here on the top left, and that opens up the project summary. From here on, we're selecting the target, and then at the very bottom, there's a plus sign. This plus sign allows us to add a new bundle, a new target to our project. So I already have it here. There's a bunch of targets here, but I'm just going to filter them by unit testing. I don't want to do ADO unit extension. I want to do unit testing bundle. Name doesn't really matter. The team, we're not running a device, so it doesn't really matter. Identifier, that's fine. You could, in theory, do your unit tests in Swift or Objective-C. Right now, even though I like Objective-C a little bit more than Swift, I'm just going to choose Swift, same project, and the target that we're going to be testing is the app that I just showed you. So very straightforward. As you can see on the left side, we have a new folder, and that opens up the Underdog Devs tests.swift file. This is a brand new target which is basically uh, its only purpose is to test the function, right? And as we can see, we have an immediate import test, which is what I was talking about. This is the framework that allows us to test. Um, it creates a new class called Underdog Devs tests, and it inherits from XC test case. There's a few functions here that we could go over. I'm just going to quickly summarize them, and we'll use them in our unit testing to class, if there is one. But all of these tests, as you can see right here, have a small diamond on the left. So if I click on that diamond, what will happen is the app gets built, the unit testing target gets built, and this function gets executed, right? If I click right here on the class diamond, all my tests will be run. So as you can see, both of these got run, they succeeded, and these did not run. Why?
Because it's set up and tear down. It happens before every single test, and then the teardown happens after every single test function.
I
And they
like that.
test.
I would say because yeah, there's no keyword test on it.
Correct. So both of you are, all three of you are completely correct. This setup with error function and this teardown with error function, they get called in between tests. So we run test example first. Sorry, we run the setup with error, then test example, then teardown with error. Then we run setup with error, test performance example, and then teardown with error. Basically, these two functions, setup and teardown, will run before and after each and every test, and they're there for you to clean your slate. If you're like, if you are loading a file, loading a database, something from core data, you can do it in setup. And if you want to prepare for the next test, if you want to dismantle it before the next test, you can do it here in teardown with error, which is what Jake was saying, right? Both of these are functions that get run before and after. But I was going a little bit more along what the other two people said, which is that, like I explained, in order for a function to be considered a unit test, it needs to have the test word as a prefix. So, for example, if I add a new function here and I save the file, I will not get the diamond on the left side. But if I do something like test new function and I save the file, I'll immediately get the diamond, right? This shows this keyword tells Xcode, hey, this is going to be run alongside everything. So get ready for that. Right now, we're not going to be setting anything up or turning anything down, and we're not going to be testing performance. All we're going to be doing is testing the validity of this. So test example function, let's rename it. Always important to have correct names. This would be test. We can test success. We can have another function that's called test error. Um, we can have a, an enormous amount of tests, right? All of these tests depend on uh, how much we want to invest on the protection of our code. Right now, I will only have one of them, so I'm only going to have test error here. And the purpose of this is I'm going to send an error to fetch planets and make sure that the result is dot failure, right? That's what I'm testing. Like if I'm offline, if the JSON is corrupt, if something happens, I want to test that and make sure that fetch planets is not returning a success. So how do I do that? First, I need to create a network controller. And this is really important. Like I'm trying to write network controller. But Xcode is telling me it cannot find network controller in scope. Here's a pro tip. If you try and write something and Xcode is not auto completing it, you're doing something wrong. Like you personally. So I'm doing something wrong here. Does anyone know what I'm doing wrong?
You need to import the project to have access to their classes.
Perfect. Yes. So that's exactly what's going on here. And time to go a little bit back into theory land. Um, what we did in the first step of the lesson was create a new unit testing bundle, right? So the unit testing bundle is completely separate from the app bundle. The app bundle on the left is the one that holds the table view. The unit testing bundle on the right is the one that holds the tests. So what I want to do is for the test function to reach into the app bundle for the network controller. And right now the line is dotted because I can't. As you can see, what I need to do is first, I need to import the function. So let's do exactly that. Import, and then Underdog Devs, that means that I'm now importing the everything that is in Underdog Devs that's available, but I'm still not auto-completing. So there's bound to be something else that I'm missing. What is it?
At testable.
At testable, yes. So if we do something like this, boom, it's immediate, right? You guys saw the change from the regular color to green, and now it's not an error, it's just a warning because Xcode is a little bit twitchy, and it's telling me, hey, please use this variable, this constant right now. What is at testable? So at testable is a way for us to get over the access modifiers. Access modifiers on Swift allow us to expand or collapse the access to our functions. I mean, it's a little bit redundant, but that's what they are. They are, right? So you can have a private function, which can only be accessed by the class it is declared in, or the structure. You can have file private, which can only be accessed in the same file, regardless if it's a different class. You have internal, which is the default, which means any class or structure that is in the same bundle can access the class. So any class inside the app bundle can access network controller. But in order for other bundles to access network controller, we would need for network controller to be marked public, which allows all bundles to grant access. Open is the last one. It's basically the same as public, but it only applies to classes. And what it allows is any bundle to access the class and subclass it. Does this make sense at this point? So the default is internal, which means that even though it's not written right here, this function is marked as internal. This class is marked as internal. So when I started importing right here, yes, that means that I get to import anything that is marked public or open, right? So because I'm on a separate bundle, that means I can reach into, but I can only see and grab anything that's public or open. Since our network controller is marked internal, I still can't see it. What is happening with at testable basically removes internal, and anything that is declared internal is elevated to either public or open, depending if it's a structure or a class. So at testable is basically going in and saying, well, if you want to import Underdog Devs with at testable, I will mark this class as open, and I will mark this function as open, right? The benefit is you don't need to change the original code. We'll leave it as is, marked internal, as it should be. But at testable is Xcode way of just like sidestepping the boundaries of the access modifiers and allowing you to unit test. So it's a special keyword. And just to complete the analogy, at testable allows us to, like, it's the bridge that allows us to test functions that are marked internal. Cool. Any questions?
Fernando, what about the file private classes?
That's a great question. So let me go back a little bit. So what happens if I want to test a file private or a private function? First of all, you probably shouldn't, right? Unit testing is all about testing behavior. So what you want to do is grab a function, add inputs into it, and validate the outputs. So usually you're testing things that your app would use in the same way your app would use them, right? So if your app is dependent on private functions, you shouldn't be testing those private functions most of the time. At testable, the only thing it does is it elevates internal. So everything that is marked as file private or private stays file private or private, which means that, for example, right now, I have marked it testable, so I can go network controller dot fetch planets, and as you can see, I have the fetch planets function. If I add a new function here, our function test, let's do fetch something else. Who can tell me what access modifier is right here?
It's internal.
Correct. Internal. Even though it's not written, it's internal, which means that in theory, if I save this function, right now in the unit test bundle, that function should be elevated so that I can see it. I should be able to do something like fetch something else. And I know I told you about not auto-completing, but Xcode is kind of slow sometimes.
I have a quick question.
Yep.
So every time when you create a new file, like a class or a structure, the full level of access is always going to be internal. Is that right?
Correct.
Awesome. Thank you.
Yep, that is correct. And so, for example, if we change this function to file private so that only any class or structure declared in this file can access it, I will immediately lose access here, right? So you'll see Xcode will tell me, hey, you're trying to access something that you shouldn't. Like that wasn't marked as internal, so you're overstepping. And this is the expected behavior of unit tests. You shouldn't be testing private or file private functions.
Got it. Thank you.
Yep. Thank you, Lydia, for that question. I actually meant to write that in the presentation, but I forgot. So yes, thank you. Let's keep going with the live demo. So now we know that the fetch planets function is right here. What we need to do is basically test it, right? So how can we test this?
Maybe, test your result. Maybe set like a constant that you can test the result towards, and if it matches or not, an expected result.
I like that. Yeah, absolutely. So that's what we're going to be doing. Basically, when we fetch the planets, we get back a result, which is either a success or a failure. Right now, we're testing the error side of it. So when I unpack the results, the cases I'm interested in are failure. And, well, these are all the cases, right? Dead planets and break. So right here, I'm interested in failure. So here, I don't want anything to happen, right? If you guys remember, I want the function to continue executing when it's the correct behavior. Since we're testing for errors, returning an error would be the expected behavior, right? This would be unexpected. If I'm testing for errors and I get back a success, that means something went terribly wrong, right? Why would I be testing for errors and getting a success back? The way we would validate that is through XCT assert. XCT assert is a very simple conditional that checks for something, whether it's true or false. So right here, I would be checking that at the very least, planets is empty, right? Because I shouldn't be getting up until this point. So the planets returned should be empty if there was an error. Actually, that doesn't even make sense. This should be false straight up, right? This will make it fail, like immediately fail if there was a success. Does that make sense? Okay, so I mean, we have our test function. We have our fetch planets. We have our assert. We only have one thing but to run it. Now, this is the fun part. If I run the function right now, will it pass or will it fail?
So it will definitely pass. Yeah, because it's making the right network request to the right endpoint.
Okay, I like where you're going with that, but remember that we're testing for errors. So what if we fetch planets right now? There would be an error if the server is down, right? So right now the server is probably not down, so it's going to be returning planets, and that would mean that it's going to fail. As soon as we hit this assert, it's going to fail. Does that make sense? I think we got, yeah. So the fun part about unit testing is that you're not testing for correct behavior in the human type of way. You're testing for consistent behavior, right? So if my function is test error, if I get here, is it expected that I got an error back? Yes or no?
No error.
Can you say that again?
Oh, there's no error because you just what you're expecting to fail. If you expect it to fail,
Yes.
that's not an
Absolutely.
error. It's going to be correct.
So I will change your words a little bit, Ida, which is that I am expecting an error. So yes, but the behavior is correct, which is exactly what you were saying, right? If I'm testing for errors, if I get an error back, then that's correct. That's what I was expecting. Then the test passes. If, however, I am testing for errors, but I get planets back, then is it expected that I got planets back? No, it's not expected. Immediately fail if there was a success. Does that make sense? So in theory, right now, if the server is up, if my network connection is right, in theory, I mean, it seems like this test should fail because the server is going to return to me a valid JSON. I'm going to parse it. And as soon as I get here, that's going to be unexpected and I'm going to fail. Does that make sense?
Sorry, just to make sure I understand.
Uh-huh.
So it's gonna fail because we received the correct data.
Yes.
Got it. Okay.
It is because I'm testing for an error, right? If let's do this, just to be extremely clear, if I were testing a success, I would ask the same questions. Is it expected that I got an error back? The answer would be no, it is not expected. Immediately fail the test. And we would add an XCT assert here with false. We were not expecting an error. And in this case, since I'm testing for success, is it expected that I got planets back? Yes, it's expected. This would be keep going. Right? So in theory, this function should pass and this function should fail because the server is working correctly. So let's try it out. So if I run, for example, test success, it passes as expected because let's set a breakpoint here just to be sure, right? Let's do a print planets just so that we can see that it's going out to the network, downloading the JSON, and correctly returning the planets. For some reason, it didn't want to. It didn't want to do that. Give me a second. Xcode is very special, isn't it? Like sometimes it's amazing and sometimes it's not.
Question.
Yep.
So you could like choose what test to run as opposed to like just running the whole file.
That is correct. So in theory, when you're automating the tests, you want all the tests to run. But if you're modifying your code, you can pick and choose which tests to run. For example, that can happen if you're working on a piece of code and you have like you're doing test-driven development, like you're fixing a bug. So you know that 4 tests fail. So you go and start and run the first test. If it fails, you go back, modify the code, make sure the first test passes. And then you run the second one individually and you keep going like that. Does that make sense?
Yes, it does. Thank you.
Cool. Yeah. For some reason, Xcode is being extremely annoying and it's not even printing my planets or setting my breakpoint. Since we're a little bit of time constrained, I'm just going to skip right through this and do this test error, which should fail, but passes. Why?
Could you
Right?
repeat that, please?
Sorry, what was that?
Could you repeat the question, please?
Yeah. So for instance, this function test error should fail the moment it receives planets, but it is passing. And I don't understand why. Like for instance, if I move the assert here, so that it always fails, regardless if it's a failure or a success, and I run it again, it still passes.
You're not doing anything with the error or the planets.
That's a good question, but it doesn't really matter. Like I have, as soon as I get this assert, it should fail. So
Maybe, yeah, I was gonna say maybe you were hitting. Oh no, well there we go. Yeah, there's probably a threading issue. Just coming back from the Swappy API, maybe to where your closure isn't being completed before the test completes.
Perfect. That's the correct answer. So going back a little bit into the theory, if you guys remember, when I said that how does exit test work? Any function that finishes execution is considered successful. So what's going on here, I chose this view load example because it's also a networking issue. What's going on here is that we are running on 2 different queues. We have the main queue and we have a background queue. We use a background queue because the network may take, I don't know, 2 seconds, 5 seconds. If I have a really awful connection, 10 seconds to return. So if we were doing everything the network requests, the parsing on the main queue, we would freeze the UI, which is the cardinal sin for mobile apps, right? So as you can see in the code here, I've broken it up into which parts run on the main queue and which parts run on a background queue. I just wrote not a main queue because it doesn't matter what queue it is as long as it's not the main queue. So as you can see, these are the parts of the code that are in this example. And number 5 is viewed load ends, right? In theory, we read them like 1, 2, 3, 4, 5, but the computer will execute them in this order, right? It'll go from 1 to 5 on the main queue. It'll add the block that contains the result to a background queue and wait for the network to return, right? So the main queue can be drawing the UI and we're waiting for the server to return the JSON to us. Once the server returns the JSON to us, the circle on the right that says 2x is executed, right? The network request returned and it was either successful and we have the planets and the JSON, or it failed and we have an error. Either way, it's going to execute on a background thread and eventually it's going to keep going, but it is going to be executed after number 5 because number 5 is on the main thread or main queue. Does that make sense? Perfect. So if that's the case, that any function that finishes execution is considered successful. So if we go back to our code, what's happening here, if I remove this, is that we're beginning to execute on the main thread. We get up until this point, and then the closure will execute when the network call returns, sometime in the future. It may be 1 second, 3 seconds, 5 seconds, we don't know, but it'll execute in the future. And so in the meantime, we go from here to here. And right here is test error finishes. Right? So what Jake was telling us was that there is a threading issue, which is that the function begins executing, it goes out to the network, and we wait, and then test error finishes. Did we hit an assert here or here? We did not. So the function passes. Run it again, it passes. Now this sucks because I don't want to do that, right? I want to test asynchronous code. So what we can do here is make sure that test error waits for the network controller to finish. And how do we do that? We do it via an expectation. An expectation is a way for us to describe to exit test that we're waiting for the network to return. In this case, right? This is a string, it's a description, it can be whatever you want. I'm just going to describe it that way. And so the expectation will stop execution at any point in time. We actually want to send the network request. And after we send the network request, we want to wait for the request to finish. In this case, to return. And we can do that just by saying, wait for expectations. We can give it a timeout, let's say 5 seconds, because I don't want to wait forever. And we're given a handler with a possible error right here. And so what this will do is it'll see the expectation, it'll execute this code and wait for this closure when it gets to this point. So we'll go 1, 2, 3, and 4. And after that, we can finish the function. Any questions?
I have a question.
So can you get some false failures, as in with this setup? Because in case it times out, won't that be a false failure?
You're absolutely correct. And we'll get to that in a second. That's a great question, Franklin. Someone else had another question?
Yeah, I wasn't understanding. I was skipped from line 36 to line 57.
Oh, okay, perfect. Yeah. So think of it this way, right? I've separated the closure here. It'll still work, but it's a little bit more visual. So when we begin this function, we're on the main thread. So we begin executing up until this point. And then this function will only execute once the network call is returned from the server. Right? So usually Swift will not stay here. They will not stop, like execution will not stop here. What will happen is you'll begin executing, you'll queue this in a background thread, and it'll get called sometime in the future. But since execution doesn't stop, it continues executing here. And this function will force it to stop. So this one will not, because we're waiting on another queue. This one will force it to stop. So we'll stop here until the network call returns. Once the network call returns, we'll continue executing. This is network call finishes. And once the network call finishes, we'll go into this closure. And after this closure finishes, we'll continue to line 64 and 65. Does that make sense?
Yeah, yes.
Cool. That's asynchronicity for you. It's annoying. It's complex. And yeah. So the only thing that we're missing right now is that we are waiting here, but in no part here are we notifying the expectation that it's done, right? The expectation here is waiting for something. it doesn't know what it is that it's waiting for. So after we have the result, I'm going to bring this back just because Xcode is, no, I'm just going to keep it that way. After we get the result, after we unpack it, we need to say to the expectation that it has been fulfilled. If I had to make an analogy, this right here is the red light. It's saying, hey, hold on, stop. You can't keep going until I get the green light from the expectation here. And this is the green light, right? So run the test, wait for the network, keep running the test, wait for the network. Network returns, we parse the result, see if it's a failure or success, and then we get the green light. We finish the network call, this red light turns into a green light, we execute this function, and we finish the test. I love the silence. Silence means you guys are learning something.
So basically, this fulfills inside of your closure still. So as soon as you get the return of your API back, it's gonna hit this function, and then it's gonna let the test to move on, right? Continue.
Correct.
Okay.
That is correct. That's why it's very important for this expectation fulfilled to be at the end of whatever I'm interested in. If I fulfill the expectation right here, we would be running into the same issue where the test will finish more quickly than I parse the results.
Got it. And so why we didn't have to do all this in the first test? Because I understood that you have to use these expectations when you dealing with requests, right? Requesting your API. So why we do not have the need to do this in the first test?
That is a great question, and it goes back to the foundation of this part of the lesson, right? Which is, why is this test succeeding? Is it succeeding because it didn't hit the assert?
Yes.
That was a horrible question on my part, because yes is the correct answer. But let me rephrase that, right? Here, this means that I'm always failing. Like, as soon as the network call returns, always fail the test, right? So if I run the test, it's succeeding always.
So it didn't succeed because it succeeded earlier. It succeeded because it had the same problem that we had with test error.
Perfect. Yeah, that's exactly the right answer, John. So this is a false positive, and it goes to the question that Franklin asked. I haven't forgot. I'll get to that in a second. Which is that right now we are maybe assuming that this function is working correctly. It is not. It is only testing that it gets to the end, but we're not waiting for the result. So this success, this is a false positive. This test is badly designed. And this goes to the heart of my original, the original question that Mohammed asked before class. This is expensive. It's code. I could have submitted this for code review, and someone else could have reviewed the code and didn't notice it, and then it goes into the code base, and now we think that the test is covering something that it's not covering. Like, you've introduced a bug in the code that tests your code. So that's awful. That's horrible. But does that answer the question, Victor? Or I don't know if it was Victor, but.
Yes, it was me. Yeah, you answered. So then basically you can also create a test function with a bug.
Yes.
Got it.
Isn't that great?
Good.
Yeah, so exactly. And now, so right now, going back to the expectations, we have the expectation. So in theory, right now, I have asserts in both failure and result. This is always going to fail. If I made this correctly, it will no longer succeed. It will wait for the expectations, wait for the network result, and fail here or here. So let's try it out. thank God. I always get nervous. And no, I never get nervous. I don't introduce bugs in my code. That was just a joke. So as you guys can see, this correctly is now waiting for the expectation. And right now we're succeeding. And since we're testing for errors, that shouldn't be. So this test failed, right?
Can I ask a question?
Of course.
So what did you do differently that makes us wait for the result this time?
The expectation. So as you can see in this test success doesn't, like XC test doesn't know that it is asynchronous, or rather it doesn't know that it needs to wait. So it just executes. This code will execute in the future. Boom, I'm done. The test succeeded. And here it starts going. Okay, this test will get called when the network returns. And here I'm waiting. So this is a loading. This is your red light. This saying, do not pass go, do not collect 200 until all the expectations have been fulfilled. So we're waiting here. The network call returns. And let's say it passes. The expectation gets fulfilled. Here, it turns from a red light into a green light. And then it keeps going to the end of the function, which is a successful test. Does that answer the question?
Yes.
Perfect. So let's go back to my presentation. I had like an hour left. So I completely misplanned this. But I think this is a good stopping point. I don't want to hold you guys for way too long. I'll just give me like 5 minutes to run over this. So finally, Franklin's question, which was really, really good. Basically, what about the network, right? Right now, we're testing that the server on the other end of the line is working correctly. So I'm not actually testing my app alone. I'm testing my app plus my network plus the server on the other end, which is detrimental, right? I can't be testing everything. So what I would really like to do to solve what Franklin correctly detected as an issue is for this fetch planet function not to go out to the network, right? I would really like it if I could, instead of doing fetch planets, if I could say, hey, you know what? Test this corrupt JSON, or test when the server returns a 500, or test when we have no planets. But I can't do that because I don't have control over the server. The API, as much as I'd like for it to be mine, the Star Wars API is not mine. So the Star Wars API is always going, like, it's designed to work correctly. So testing these scenarios is going to be impossible right now. And what we should do in theory, and we'll probably cover that in the next lesson if there's one, is this URL session is embedded into the fetch planets function. And I wish that it wouldn't, so that I could replace it with something like a mock session, something that injects JSON, whatever it is, right? That produces a 500 error if I want, that produces a corrupt JSON if I want, things like that. And I would really like to do that. And you can, if you know about dependency injection. Dependency injection is basically a process or a way of thinking or coding in which we split the responsibilities up from the function that is doing too much. Right now, Fetch Planet is doing two things, and I can't count, so there's three things. I modified the slides at the last minute, but it's doing 2+1 things. It's building a request based on inputs. It is handing over the request so it goes out to the network, and then it's handing over the data to Codable so that it is parsed. I would really like so that this, so it goes to the network, is not part of the function. And it shouldn't be, right? When you fetch planets, you could be fetching planets from a cache. You could be fetching planets from core data. You could be fetching planets from user defaults. You shouldn't, like, the function shouldn't be aware that it is fetching planets from the server. It should be fetch agnostic, if that makes sense. And just so that to complete the analogy, what I would like to do is right now your session is embedded. It's used hard-coded into the function. What I would like to do is use a protocol, which is a mask, an interface, someone that pretends to be something, so that I can inject URL session if we're on the app, or I can inject mock session if the unit tests are running. Right? That's what I would love to do. And unfortunately, we're run out of time. So I'm not going to do that. It would take us like probably around 30 or 40 minutes. But it's a rule from great magicians to always leave people wanting more. So with having said that, what I can tell you is two things. One, I will upload the code with dependency injection. I'll make two branches. One branch will be this branch, which is the branch that we saw during lecture. And I'll keep going with the dependency injection so that you guys can see how I would have done it with a protocol. All of that code will be uploaded to my GitHub. And if you have any further questions, just ping me on I was going to say on Slack. Ping me on Twitter. I'm at from junior to senior. If you want to keep going by yourself, which I encourage you to do, there's a bunch of great articles that I found that explain unit tests, both positives and negatives. I recommend all of these, especially the last one is straight from the horse's mouth. Apple documentation explains to you a lot of things that we didn't cover. And yeah, I know I've spoken a lot, but and I'll let you guys speak in a second. Just hold on. I have the microphone right now. The last thing I will say is Underdog Devs. Again, it's the reason why we're here. The reason why I volunteered to lecture you guys. It's not only so that you can listen to my amazing, horrible jokes. It's because we really need help at Underdog Devs. If you guys want to help in any way, shape, or form, maybe you don't have time. Maybe you can donate a couple of books. Use MacBook, a brand new M1 Mini. Hey, I don't blame you. We could definitely use one. There's people that need to code. It would be really, really great. Even if you can't do any of those things, following Underdog Devs on Twitter and Rick, that's great so that you can keep listening and keep your ear to the ground and just come to the next activities that we organize. And yeah, that's it.